The craftsmen in Pakistan utilize a sand casting technique to produce durable copper pistons for engines. After a simple machining round on the lathe, these copper pistons are ready for use. When the piston of an imported engine suffered severe wear and tear, and with no replacement parts available locally, the owner turned to a small workshop. For a high-precision component like this piston, the craftsman wrapped the mold in the sponge to slightly enlarge its diameter, allowing for additional machining space later. Once the piston met the sand casting requirements, the craftsman reused the hardened sand by tossing it into a mixer to break it down into powder. Then, using a blowtorch, they gradually heated the sand, raising its temperature to blend with used engine oil, enhancing its stickiness. After 10 minutes of mixing, to prevent the sand from adhering to the piston, the entire surface was coated with a release agent, followed by a layer of parting sand. This ensures that even if the sand fully covers the piston, it can still be easily demolded. Once the sandbox was filled and the sand was compacted, vent holes were punched to prevent the mold from cracking due to the heat generated during casting. Once everything was set, the top cover was also filled, and with the casting opening left in place, the mold was ready. The piston was then separated, leaving a cavity inside for the copper to be poured. To prevent the hollow mold from collapsing, the craftsman heated it with a blowtorch, fully hardening the top and bottom molds. After creating the mold, they opted to remelt a copper-plated iron turbine due to the high cost of producing copper and the limited raw materials available. As the turbine was heated, the brass outer layer separated. With the furnace temperature rapidly rising, the copper was fully melted within 3 minutes and ready to be poured into the mold. Since the piston is relatively small, the casting process was swift. Once formed, the piston was demolded promptly to avoid the hardened sand, which made demolding difficult. After cleaning up, they used an angle grinder to remove the copper from the casting gate. However, the dimensions were still off, requiring further machining on their basic lathe. The rough surface was shaved down to restore the original smooth finish. Although machining altered the dimensions slightly, the sponge's initial thickness was fully trimmed off, restoring the piston to its original size. After confirming the outer diameter of the piston head, the base was also trimmed to prevent any alignment issues with the chuck. Despite using a simple lathe, their precision was high enough to ensure the piston's proper function. After some final pre-processing inside and out, the piston needed grooves cut along its edges to fit the piston rings. Using the original piston rings as a reference, they replicated the grooves, then filed away any burrs to ensure they wouldn't affect the piston's performance. Finally, when the connecting rod needed to be secured to the piston, the sides were drilled with a bench drill, completing the copper piston. What do you think of these copper pistons made by the craftsmen in Pakistan? Out of 10, how would you rate them?